Variables and mutability in Rust. Question: how do you declare variables in Rust, and can you change their values? Answer: in Rust, you declare variables using the let keyword. By default, once you give a value to a variable, you cannot change it later. If you try to change it, the Rust compiler will give you an error saying you cannot assign twice to an immutable variable. This is a safety feature in Rust that helps prevent bugs in your code. Why immutable by default? Rust's philosophy is safety and concurrency. Immutable variables prevent accidental data races and unintended side effects. The compiler can also optimize immutable bindings more aggressively. Question: what does mute do in Rust variables, and what is its main rule? Answer: in Rust, a variable is immutable by default, which means its value cannot change. When you add mute, you allow the value to change. For example, let mute x equal 5 allows x to become 10 later. The important rule is that mute only allows changing the value, not the type. If x starts as an integer, it must always stay an integer. You cannot assign a string or another type to it, even if it is mutable. Question: what is shadowing in Rust, and how is it different from mute? Answer: shadowing in Rust means you create a new variable with the same name by using let again. Each time you do this, the old variable is replaced by a new one. This is actually different from mute because mute only changes the value of the same variable. Shadowing creates a new variable, so it can really change the value step by step, and it can even change the type, which mute just cannot do. In Rust, shadowing can also happen inside inner blocks. When you use let x inside a block, it creates a new variable that only exists in that block. This inner x hides the outer x only while you are inside the block. When the block ends, the inner x is gone and the outer x keeps its original value. Constants in Rust are values that never change. They are defined using const, and they are always immutable, so mute is not allowed. A constant must have a type written explicitly, and its value must be known at compile time. Constants can be declared in any scope, even globally. By convention, their names are written in screaming snake case. Runtime function calls are not allowed when defining constants. Yes, constants in Rust can be declared in different scopes. You can define a constant at the global or module level, and you can also define it inside a function or a block. No matter where it is declared, a constant is still evaluated at compile time, and its value can never change. What are static variables in Rust, and how are they different from const? Static variables in Rust are values that live for the entire program and have a fixed memory location. They are defined using static. Like const, they usually cannot change, but static variables can be made mutable using static mut. When a static variable is mutable, you must use unsafe code to read or write it. Unlike const, static variables are stored in memory and shared across the program. What is type inference in Rust, and when do you need explicit types? Type inference in Rust means the compiler can automatically figure out the type of a variable from its value. For example, if you write let x equals 5, Rust understands that x is an integer. This makes the code shorter and easier to read. However, you can also write the type explicitly when you want more control or clarity. Explicit types are often used when the exact type matters, such as choosing a specific integer or floating point size. How does Rust infer types when they are not known at first? Rust can delay type inference until it sees how a value is used. For example, when you create an empty vector, Rust may not know its type yet. When you later push a value into it, Rust uses that value to decide the vector type. You can also help the compiler by writing the type explicitly or by using special syntax to specify the type at creation time. Question: What does destructuring with let mean in Rust? Destructuring with let in Rust means breaking a complex value into smaller parts and assigning them to variables in one step. For example, you can take values out of a tuple, a struct, or an array and store them in separate variables. This makes the code clearer and avoids manual indexing or field access. You can also ignore parts you do not need and even handle nested structures in a simple way. Question: what is mutable destructuring in Rust? Mutable destructuring in Rust means you can make individual variables mutable while unpacking a tuple or similar value. By writing mut before a variable name, you allow only that variable to change later. You can also mix mutable and immutable variables in the same destructuring. This gives you fine control over which values can be modified and which ones must stay the same. Question: what does the underscore mean for unused variables in Rust? In Rust, using an underscore helps you avoid warnings for unused variables. If a variable name starts with an underscore, Rust will not warn you even if you never use it, and the value is still stored. If you use just a single underscore, the value is completely ignored and dropped right away. This is useful when you receive a value but do not need it at all.
Question: what is the important difference between using underscore name and single underscore in Rust? In Rust, there is a critical difference between a variable like underscore s and using just underscore. When you write let underscore s equals s, the value is still assigned to a variable, so ownership is taken and the original s is moved. This means you cannot use s afterward. But when you write let underscore equals s, the value is ignored and ownership is not taken, so s is still valid and can be used later. This is very important when working with owned values like string. Question: how does Rust handle uninitialized variables? Answer: Rust does not allow you to use a variable before it has a value. If you declare a variable without initializing it, you must assign a value to it before using it. This is called deferred initialization. The compiler checks this at compile time, so you cannot accidentally read an uninitialized variable. Question: how does Rust make sure a variable is set before you use it? Answer: Rust checks all possible paths in your code to make sure a variable is set before you use it. If you have an if statement, Rust looks at both the if part and the else part. If you set the variable in both parts, it is safe and you can use it. But if you forget to set it in one part, like leaving out the else part, Rust will stop you and show an error. This prevents bugs where you might try to use something that has no value.
Question: can you change the value of a variable that was declared without a value at first? No, you cannot change it. In Rust, you can declare a variable without giving it a value right away. But once you give it a value for the first time, you cannot change it later, unless you make the variable mutable. If you try to assign a new value to the same variable, Rust will stop you with an error, because variables are immutable by default. Question: what happens to a variable when it goes out of scope in Rust? When a variable goes out of scope in Rust, the memory it used is automatically freed. This happens when code inside curly braces finishes running. Rust calls a special function called drop at that moment to clean up the memory. After that, you cannot use the variable anymore. If you try, Rust will show an error because the variable no longer exists in that part of your code. This automatic cleanup helps prevent memory leaks. Question: in what order does Rust clean up variables when they go out of scope? Rust cleans up variables in reverse order of how they were created. This is called last in, first out, or LIFO. The variable that was created last gets dropped first, and the one created first gets dropped last. So if you create 3 items, the third one is cleaned up first, then the second one, and finally the first one. This matches how variables are stored on the stack and helps ensure proper cleanup. Question: what happens if you create a new variable with the same name inside a loop? When you use the same variable name inside a loop, you create a new variable that hides the old one. This is called shadowing. The new variable inside the loop is separate from the one outside. If you try to change it, you might get an error if you didn't make it mutable. Also, if you change only the inside variable, the outside variable never gets updated. This can cause an infinite loop if you meant to change the outside one. The fix is to work directly with the outside variable instead of shadowing it. Question: can you change whether a variable is mutable by shadowing it? Yes, you can. Shadowing lets you create a new variable with the same name but different properties. If you start with a mutable variable, you can shadow it with an immutable one to make it unchangeable. And if you start with an immutable variable, you can shadow it with a mutable one to make it changeable. The old variable goes away and the new one takes over with its own settings. This gives you flexibility to adjust mutability as your code runs. Question: what is let else in Rust and why is it useful? You can use let else, which is a feature added in Rust 1.65. It lets you unpack an option in one line. If the option has a value, you get that value and can use it after the line. If the option has no value, the else part runs, and you must leave the function or block. This makes your code cleaner because you don't need nested match statements just to get a value out. You handle the empty case first and then work with the value directly. Question: how can you check multiple options at the same time in Rust? With let chains, which are a feature being worked on for Rust, you can check multiple options together in one if statement. You use if let for the first option, then add and another if let for the next option, and so on. You can even add extra conditions after that. This lets you unpack several values and check them all in one place. It keeps your code clean instead of writing nested if statements. Question: what happens to a variable when someone borrows it in Rust? When you create an immutable reference to a variable, that variable becomes frozen. You cannot change it while the reference exists. This is because Rust wants to make sure the value stays the same for anyone using the reference. Once you stop using the reference, the variable becomes unfrozen, and you can change it again. Rust's non-lexical lifetimes feature helps by letting you use the reference, then change the variable after the last time the reference is used. Question: can you change something even if it is declared without the mute keyword? Yes, you can, using interior mutability. Rust has special types like cell and refcell that let you change values even when the variable itself is not marked as mutable. Cell works for simple types and lets you set and get values. Refcell is for more complex types and checks borrowing rules at runtime instead of compile time. This is useful in some situations, but you need to be careful because refcell moves some arrow checking from compile time to runtime. If you break the rules, your program will panic. Question: where can you use the mute keyword in Rust? The mute keyword appears in several places in Rust. You use it when you want a variable to be changeable, like with let mute. You use it for mutable references with &mute. You can mark function parameters as mute to change them inside the function. When pulling apart a struct, you can make some fields mutable with mute. You also use it for raw pointers that can change. And in methods, you use mute self when you need to change the struct itself. Each use of mute gives permission to change something in that specific context. Question: what does mute mean on a function parameter? When you put mute on a function parameter, it means the local copy inside the function can be changed. But this does not affect the variable you passed in from outside. If the function takes ownership, the outside variable is moved and cannot be used anymore. The mute only lets you change the value while the function has it. After the function ends, the value is gone. The caller's original variable, if it still existed, would not be changed because ownership moved completely into the function. Question: if a variable is mutable, can all references to it change the data? No, not all references can change the data. Even if the original variable is mutable, when you create an immutable reference to it, that reference cannot change anything. You also cannot change the original variable while the immutable reference exists. The mutable nature of the original variable does not pass through to references. Each reference has its own rules about mutability. An immutable reference always blocks changes, no matter where it came from. Question: does Rust warn you if you use mute but never change the variable? Yes, Rust gives you a warning if you mark a variable as mutable but never actually change it. This is because mute is a signal that you plan to modify the variable. If you do not modify it, the mute is not needed. Rust helps you keep your code clean by pointing this out. You can remove the mute to make your code clearer and get rid of the warning. This way, when you see mute in code, you know that variable really does change somewhere. Question: how can you stop Rust from warning about unused variables or unused mute? You can add special annotations called attributes to tell Rust not to warn you. For a single variable, you can put allow unused variables above your code. If you want to allow unused mute, you can use allow unused mute. These go above the function or at the crate level to apply everywhere. This is useful when you are learning or testing code and you know the warnings are not important right now. But in regular code, it is better to fix the warnings instead of hiding them. Question: why does a closure that changes a variable need to be declared mutable? When a closure changes a variable from its environment, it captures that variable in a way that allows mutation. This means the closure itself becomes something that changes when you call it. In Rust, you must mark the closure as mutable with letMut to show that calling it will modify its captured data. If you forget the mute keyword, Rust gives an error because you are trying to change something without permission. The closure's own ability to mutate comes from being declared mutable itself. Question: what is const generics in Rust and why is it useful? Const generics in Rust let you use a constant value, like a number, as part of a type. For example, you can create an array with a size decided at compile time, like 5 or 10. This is useful because it makes your code more flexible and safe. You can write one function that works with many different sizes, instead of writing many similar functions. It also helps Rust check errors at compile time instead of runtime. Question: what is const fn in Rust and when is it used? A const fn in Rust is a function that can run at compile time. This means the result can be calculated before the program starts. For example, a factorial function can be used to create a constant value during compile time. This makes the program faster because the work is already done. The same function can also be used at runtime if needed, so it is flexible and efficient. Question: what is the difference between using &mut and roughmut in Rust? &mut and roughmut do the same thing, but in different places. &mut is used to create a mutable reference to a value. Roughmut is used in patterns, like when you are destructuring or matching, to bind a value as a mutable reference. They both give you a mutable reference that lets you change the original value. The choice depends on where you are in your code. Outside of patterns, you use &mut. Inside patterns, you use roughmut to achieve the same result. Question: if you make a struct variable mutable, does that let you change all its fields? Yes, in Rust, mutability applies to the whole variable. If you mark a struct variable as mutable with letMut, you can change every field inside it. Rust does not let you make some fields mutable and others not. If you want some fields to change and others not, you need different approaches. You can use interior mutability types like cell or refcell for the fields you want to change while keeping the outer variable immutable. But when you use letMut, all fields become changeable. Variable declaration.